And almost live from room 115, it's Miss Sanogo!
Children Make Terrible Pets by Peter Brown. One morning, Lucy was practicing her twirls when she noticed she was being watched. "Hello? Who's there? I can smell you behind those bushes, so just come on out." Squeak! When her secret admirer scurried into the open, Lucy could not believe her eyes. "Oh my gosh! You are the cutest critter in the whole forest!" Squeak! So Lucy brought the critter home to show her mom. "Mom, look what I found outside! I call him Squeaker because he makes funny sounds. Squeak! See, isn't he the cutest? Can I keep him, please?" Lucille Beatrice Bear, don't you know that children make terrible pets? Aw, come on, Mom. Look how sweet he is. He won't be any trouble, will ya, boy? Squeak! Oh, all right. You can keep him on one condition. Squeaker is your responsibility. I will not take care of him for you. Thanks, Mom. Squeaker is going to be the best pet ever. You'll see. Lucy and Squeaker were inseparable. They played together. They ate together. They napped together. Lucy and Squeaker did everything together, but it wasn't all fun and games. He was impossible to potty train. Squeak! He ruined the furniture. Squeak! He caused problems wherever he went. We don't throw food at tea parties. Squeak! And just when Lucy thought things couldn't get any worse, Squeaker disappeared. Squeaker? Lucy checked the usual hiding spots, but her pet was nowhere to be found. "Here, Squeaker. Come here, boy. Squeaker? Squeaker, where are you?" Lucy had almost given up hope when her sensitive nose caught a whiff of her Squeaker. Lucy followed Squeaker's scent this way and that across the entire forest until finally she found Squeaker! But something had changed. Squeaker didn't seem like a pet anymore. Lucy knew what she had to do. Goodbye, Squeaker. Squeak! Squeak, squeak, squeak. Woof! Lucy had a lot to think about on her walk home. Squeaker belongs with his family. I'm really gonna miss that little fella. I guess some critters just aren't meant to be pets. Maybe it's all for the best. By the end of the day, Lucy had learned one very valuable lesson. You were right, Mom. Children do make terrible pets. They really are the worst. The end.
The introduction to last week's episode gave us a little sneak peek into this week's science experiment, roller coasters. Have you ever ridden a roller coaster before? Have you ever wanted to design your own? Roller coasters are fascinating machines, whether you are riding them or watching them from afar. They bring up mind-boggling questions such as, what makes a roller coaster go? How do the cars manage to stay on the tracks as the roller coaster dips and curves? How do roller coasters manage to move at such high speeds? Well, this week, we are going to design and build our own roller coasters, and we'll find out the answers to these questions and more along the way. For this experiment, you can use recyclable materials that you can find lying around your house. I waited a few weeks to stock up on cardboard tubes from old paper towels and toilet paper rolls. If you don't have many of these on hand, you can use any type of paper, like construction paper or paper from magazines or other recycled paper that you might have, and roll them up to make tubes like this. You can use them as the ramps for your roller coaster. You will also need plenty of tape, an object to test out your roller coaster, like bouncy balls, ping pong balls, or marbles, and a pair of scissors. Like all scientists and engineers, before we start building and testing something out, we have to plan with some goals in mind. Imagine you are an engineer tasked with building your own roller coaster. What do you want your roller coaster to do? Will it have super fast turns and deep falls? Will it move in a straight line, or will it twist and turn? How high do you want the roller coaster to be? Will there be any hills along the way? I decided to create my roller coaster with 3 goals in mind. My first goal was for each section of my roller coaster to be at least 6 inches off of the ground. I wanted to challenge myself to build a somewhat tall structure that was able to support sudden steep falls. My second goal was for my roller coaster to at least have 1 hill. By hill, I mean this, a point where my object, the ball, has to be able to travel upwards a short distance, like climbing a hill, and fall back down again once it reaches the other side. My third and last goal was for the ball to land into this tissue box, which means I would have to design the end of my roller coaster to support the ball traveling and landing in that direction. Now that we have our goals and material, let's start building. I used a flattened out cardboard box as my base for building my roller coaster. You need something sturdy to prevent it from falling over. Next, you will need to build the supports for your roller coaster. These supports will hold up the ramps or the tracks that the object will travel through. I used old plastic cups that I have had for a while as my main source of support. As you can tell, these plastic cups have been warped after many washes and uses. Always remember to reuse plastic and not throw them away in order to help our environment. I also used cardboard tubes and other recyclable materials as my supports. I had to keep in mind how tall I wanted to make each support. Remember, I have a goal of at least 6 inches off of the ground. Also, most roller coasters start with a steep dive at the start, so I wanted to recreate that with my own design. That is why I have supports of different heights. Next, we are ready to start laying down the tracks. I used cardboard tubes to help guide the direction of travel. It took a lot of trial and error to put them in place. Now, for our second challenge, getting the ball up the hill. How is this possible? We have the most potential energy at the beginning of the roller coaster. Remember, in previous episodes, we've discussed potential energy, which is the energy stored by an object due to how it's positioned, like this ball about to travel down a steep path. The higher that an object is lifted from the ground, the greater the potential energy. So, because the starting point of my roller coaster is at the highest point from the ground, it has the most potential energy. As the ball starts to roll down the steep path, the ball's potential energy is changed into kinetic energy, the energy of motion. The ball rolls faster and faster as it gets pulled by Earth's gravity towards the ground. However, once the ball reaches the small hill and begins to roll up, the increase in height of the hill causes the ball to slow down as it builds up potential energy once more. So, keeping this in mind, my starting point for my roller coaster has to be high enough to where the ball would have enough potential energy to change or convert into an energy of motion. If my ball doesn't have enough kinetic energy, it won't make it up the hill and will get stuck. This is my completed roller coaster, the Taki Coaster. After some trial and error, I was able to complete my third goal and design the ending tracks to guide the ball into the tissue box. Take a look at these next few clips of different angles of the roller coaster in motion. Now, it's your turn. Try this for yourself at home. What are some fun goals and challenges that you want for your roller coaster? Maybe you'll want to create a really long one, or a roller coaster with several hills. Maybe you'll have fun challenging yourself designing a roller coaster with many twists and turns. Whichever you decide on, be sure to share and send in your work. Have fun, engineers! I used red as I found that it showed up the best in this experiment.
Oh!
It's about
Oh!
You're spelling.
Oh, sorry.
You gotta leave some space.
1 to 2 inches of air.
Now I'm gonna put these in.
Then, take 1 or 2 of the pieces and start dropping them into the top of the container. Look closely. What do you observe?
It's cool.
It's so cool! Look at it! It's
So,
turning to
what
a
exactly
bubble.
is happening here? Well, the Alka-Seltzer tablet reacts with the water to make tiny bubbles of carbon dioxide. These bubbles attach themselves to the blobs of the colored water and cause them to float to the surface. When the bubbles pop, the colored blobs of water
my
sink
God,
back to the
it's
bottom
so
of the
cool.
bottle, while the carbon dioxide gas escapes into the air. Then, the whole thing starts over until the Alka-Seltzer is used up.
This is a little fun experiment that you can do at home. You need a balloon, shaving cream, food coloring, something to break it with, and a board and tape. So we'd go like this.
So here Oh my god, now it's just going in big clumps. You know, it reminds me of like this that I got at the Yosemite National Park. It reminds me of that. Because it looks kind of like it. Because there's like these little balls in here, and there's little balls in here. And we're planning to make one.
Do you have a super cool science experiment that you want featured on our show? Send me an email including any videos or pictures of your experiment. Remember to ask an adult for permission first and for help.
With this fancy picture frame and fancy music. Before we dive into this week's posted question, let's talk about what you sent in from last week. Many of you reviewed your favorite books. This happens to be my favorite book, Silly Jokes for Kids, because it has a dinosaur on the front who is drinking fancy tea. And it just so happens that I used these jokes for my comedy show. Okay, bye for now.
Last week's posted question was, give your favorite book the spotlight. What book have you enjoyed reading lately and why?
Hello, my favorite book is the Lulu collection. Down here, there's all 4 books of the series, and I like it because she does all the crazy things. Like in this one, she gets a brontosaurus for a pet. This one I haven't quite read, but I think she gets in trouble walking the dog, and and then in Lulu, Mysterious Mission, I think I haven't read this one either, so I think that she goes on a secret mission, and it's really hard for it's really hard. And then this one I've read, it's where she goes to this mysterious camp and she gets a sister. She gets all bad-tempered because she is really bad-tempered. Really bad-tempered. She's used to being spoiled, but in the first book, Lulu gets a brontosaurus. She learns to be a little nicer, but let me tell you, some of the time, she is not nice. Bye!
Oh, that's a really good one. Oh, how long have you been waiting there? Sorry, I lost track of time. This is such a good book. Okay, you know what time it is. Time for the posted question of the week. Bye-bye.
This week's posted question is, You are stuck on a deserted island for a week. You can only bring 3 things with you. What items will you bring? Also, electronics and technology will not work on the island. Do you have an answer to this week's post-it question? Send your answers to me. Ask an adult for permission. My email address is msanogo@cps.edu. If you've ever witnessed the motion of a waterfall, whether on TV or in real life, you've probably noticed how powerful the water flows and moves, from quiet trickles to loud and roaring downpours. And the waterfall manages to do all this movement while taking up only a certain amount of space. This week, we are going to recreate the powerful movements of waterfalls while also keeping our active bodies in one place. We will move up and down, but not side to side.
Hi, Miss Sanogo. This is how I exercise. First I jump, then I go play soccer, then I play basketball.
Do you have a super fun exercise or workout activity that you want featured on our show? Ask an adult to help you record your exercise. Then, send your videos to msanogo@cps.edu. Taki and I can't wait to sweat it out with you.
Hey, Taki. Hi, Miss Sanogo. Wait, what are you doing here? Did you follow me to the Seahorse Cafe?
Yeah, I just wanted to make sure that you didn't need any help.
Well, funny you should mention that. I just met with Agent T-Rex, but he left in a hurry. He said an evil villain was after him.
Oh, Taki, I'm so glad we finally got to meet at last.
Me too. I'm so happy we could share this yummy drink together.
I have finally found you at last, Agent T-Rex. Oh no, Taki! Take my money, I've got to run. He's after me.
Oh no! Mathematicians, we're gonna need your help. I just met with Agent T-Rex, but he left in a hurry. He said an evil villain was after him. He threw money at me and then asked if I could pay the bill. But I don't know how much money I should be getting back from the waiter. Help me!
Okay, walk me through the problem, Taki.
Okay, this is the Seahorse Cafe's menu. Agent T-Rex ordered the Lobster Delight, the Turf and Surf, and the Triple Taki ice cream scoop for dessert.
Wow, he was hungry.
That's what I said.
Okay, so how much money did he give you before he ran away?
He gave me $50 to pay the waiter.
Okay, great. And you want to know how much change he should get back from the waiter after he pays for the 3 meals that he ate?
Yes, how
Help me, quickly! We know what he ordered, and we know how much he paid. How much change will he get back from the waiter? Last week, our mathematicians had to use their money skills in order to decode a secret message from Agent T-Rex. Let's take a look at their work.
So what I did was I found the amount of each and I put check marks next to the ones I'd finished and put the letters there, and I ended up with Seahorse Cafe. And I hope they don't serve seahorses there. That would be disgusting.
Okay, so Celine got the answer for the problem. What did you get, Celine?
I got Seahorse Cafe.
Do you have a solution for our math problem of the week? Email me your response. And for a bonus challenge, is there more than one way to solve the problem? I can't wait to hear from you.
It's time for Talkie the Talking Triceratops time!
Wait, that's too long!
Triple T time!
Yay!
I have a trick for you.
Okay, what is it?
Why do vegetables like listening to music?
I don't know. Why?
Because they like to dance to the beat. Get it? Beat? Knock knock.
Who's there?
Butter.
Butter who?
Butter, let me in. I gotta go to the bathroom. Knock knock.
Who's there?
Yeah.
Yahoo!
Yay, you're excited to see me.
He said Yahoo. Get it?